Why is the Earth's core hotter than the Sun's surface? Did you know the Earth's core is around 6,000 degrees Celsius? That's hotter than the Sun's surface, which is around 5,500 degrees Celsius. So why is the Earth's core so hot? When the Earth formed about 4.5 billion years ago, it was a hot, molten ball of rock and metal. The core, which is the Earth's center, is about 12,000 kilometers below the surface. And because it's so deep inside the Earth, it's subjected to immense pressure. All that pressure makes the core incredibly hot. In fact, the temperature at the Earth's core is around 6,000 degrees Celsius, which is more than 10 times the temperature on the Sun's surface. But it's not just the pressure that creates all that heat. There's also something called radioactive decay. Most of the Earth's heat comes from the decay of radioactive elements in the core, like uranium, thorium, and potassium. As these elements decay, they release a lot of energy in the form of heat. In fact, scientists estimate that there are around 500 million nuclear reactions happening in the Earth's core every second. All that nuclear energy makes the core incredibly hot. But if the Earth's core is so hot, why doesn't it melt? Well, it turns out that the intense pressure in the Earth's core actually keeps it solid. That's because pressure and temperature have an effect on a material's melting point. For example, ice melts at 0 degrees Celsius, but if you put enough pressure on it, like what you find at the bottom of a glacier, it will stay solid even at 100 degrees Celsius. This is called ice. And it happens because the pressure squeezes the water molecules so tightly together that they can't move around freely, which is what you need for melting. It's the same thing with the Earth's core. The intense pressure keeps the iron and nickel atoms from moving around freely even though the temperature is 6,000 degrees Celsius. So that's why the Earth's core is hotter than the Sun's surface. It's because of the immense pressure and radioactive decay that's happening down there. Thanks for watching.